Welcome to this video where we will review exercise 1, and this is starting to build out the university registration data model. So what we want to do here is we want to take the simplified route. Obviously a university registration data model can get quite extensive, but we want to just look at the basics for now. You can see here's a list of the entities. Here are the instructions here. And here are a list of attributes. So what we want to do here is list out at least 5 other additional entities and then fill in all of the attributes. Here is a start. So we have course, that's one entity. Course ID is an attribute, and course name is another attribute. So fill in the 2 additional attributes for course, and then list out what you might add for the entities for a university registration data model. Some are obvious, but possibly some are not. There is also a project document to take a look at. So after you've completed this exercise, go ahead and take a look at that and review it and see if what you can draw, what conclusions you can draw from what you did as far as the entities and the attributes and what's in that document. In this video, we will review what you should do for exercise 2. So take all of the entities that you listed in exercise 1 and use this template or the pattern here in this file. You can copy paste these boxes. You can copy paste this line here. Fill in the entity names, and you can just overtype this and fill in the relationships between your entities, and you can arrange these any way that you need. Don't worry about adding the attributes for now. You can certainly key in the attributes if you want to. If you need an example, page 2 has an example here. So the most important thing is arranging the entities, and the entities are the names up here at the top. You can list the attributes below certainly if you want to, but that is optional. And use the lines, and don't worry about the direction, just to identify the relationships. And then there is a document under Project 2. Take a look at that, see how that was done, and see if it is aligned with what you did, and what did you do different from it. End. Welcome back to this course, Introduction to Database Design, presented by Coding Bootcamps. This is a sample project, the ERD exercises, Entity Relationship Diagram exercises. So in this exercise, we are going to take a look at creating entity relationship models based on some criteria that were given. So we can see here in exercise 1, we have a manufacturer. And a manufacturing company produces products. The following product information is stored, so it's maintained on the system. We have the product name, product ID, and the quantity on hand. The products are made up of many components. Each component can be supplied by one or more suppliers. The following component information is kept: component ID, the name, the description, the suppliers, in that who supplies them, and the products in which they are used. And if we look at figure B for this exercise, we will create an ERD to show how you would track this information. So we want to show entities, the names, the primary keys, and the attribute for each of the entities, and the relationship between the entities, and also the cardinality. We went over cardinality in our course. The assumptions we're going to make: a supplier can exist without providing any components. A component does not have to be associated with a supplier. A component does not have to be associated with a product. Not all components are used in all products. And a product cannot exist without components. So these are the business rules that we have to establish. So these are these rules and these assumptions cannot happen on their own. So none of this is really database driven. These are actually rules that we are getting from the enterprise. These are rules that we have to implement in order to create our entity relationship diagram. So in order to successfully model an enterprise, we have to know the rules of the enterprise. So we want to discuss this with analysts. We want to discuss this with managers and possibly others that are involved in the process, in the business process we're trying to model. So as we move down here, we can see that first thing we are going to come up with our beginning our model for our components. So we'll have our component ID, our component name, and our component description. One thing that's very important, we have to understand, how do we keep each component identified uniquely? So we're going to call that our PK, or our primary key. So that's going to be our component ID. And that makes sense. That sounds very, very typical, a good practice approach. So we have our component ID, our component name, and our component description. That, for our purposes right now, is enough to describe a component. There could be more, but this is enough to get us out of the starting gate. So for a product, we are going to have a product ID, a product name, and quantity on hand. And a product is going to be unique in our system using product ID, so that'll be our primary key. Then we're also going to have supplier. And again, for us, we're going to have a supplier ID, a supplier name, and suppliers are going to be kept unique by using supplier ID as our primary key. So we'll enlarge this a little bit, and then we'll move down here, and we can see we have two more entities. We have our component supplier with our component supplier ID and our supplier ID. And we can see here that we have a compound primary key, which is comp ID and supplier ID. And then we have build, which also has a component ID, a product ID, and a quantity of components. And we see here our primary key is also a compound primary key, where we have together component ID and product ID. So here we would use some tool. Maybe it is Visio. There are lots of tools on the market that help us build these entity relationship diagrams. But what we want to do is first put out our component, our supplier, and possibly product. So that's what we started with up here. And they were relatively simple. So again, we have component, we have the three attributes, and we have the primary key component ID. So here we have our component name, description, and we have identified here as our primary key, we have the component ID. Then over here we have supplier, and we said with supplier we have the two attributes, supplier ID and supplier name, and we have as the primary key supplier ID. And for product, we have the three attributes. We have the product ID, product name, and quantity on hand. So we would build this right here. We have the appropriate product ID there. Then we said for component supplier, it would be a combination of component ID and supplier ID. And the two primary keys together, the compound primary key, would be component ID and supplier ID. But also these would be foreign keys because the way that they relate. So notice this is relating right here based on supplier ID. And component ID is also relating here. So these foreign keys are primary keys in a different table. And we are actually able to bring in the supplier name because of the supplier ID. And from here, we are also able to bring in component name and description based on that relationship there. So we can see there how these tables relate. And this is drawn in a way that that relationship is very clear. So this is a good drawing. And we can see here our build table also has our component ID, our product ID, and quantity of components. And this is pointing back to the product ID with its foreign key. And both of these together, these two keys together, or attributes, make up the primary key for this table. So we can see that there, but we can also see component ID is pointing back up here to the component table. So let's zoom out a little bit here again and try this on your own. Just sketch this up. You can pick a tool. It can be PowerPoint. It can be Visio. It can also be other tools that are out there. Usually tools that support ER diagrams or entity relationship modeling. There is a free version, so please do go out and take a look and think about what is involved in modeling the enterprise or the business unit for your application. Let's take a look at exercise 2. So exercise 2 here, again, they're giving us the business rules. So we have to model or create an ER diagram for a car dealership, and the dealership sells both new and used cars, so that's important, and it operates a service facility, and we want to base our design on these business rules. A salesperson may sell many cars, okay, so we're getting into cardinality here, but each car is sold by only one salesperson, and so that's important, that relationship. So each car has a salesperson, but a salesperson may have many cars. A customer may buy many cars, but each car is bought by one customer. So again, that's important. A salesperson writes an invoice for each of the car he or she sells. A customer gets an invoice for each car that he or she buys. A customer may come in to have his or her car serviced. That is, a customer need not buy a car to be classified a customer. Okay, and another important rule. These are all rules that are looking for a rather, I'm not going to say completely complex, but something a little more than simple cardinality model. When a customer takes one or more cars in for repair or service, one service ticket is written for each car, and a car dealership maintains a service history for each car that is serviced. These service records are referenced by the car's serial number. So maybe this is some uniqueness here we're getting. A car brought in for service may be worked on by many mechanics, and each mechanic may work on many cars. A car that is serviced may or may not need parts. Adjusting a carburetor or cleaning a fuel injector nozzle may not require providing new parts. So this is just an example of servicing where new parts are not needed. Also possibly filling tires. If a tire's a little low, obviously we are not going to replace the tires in that case. So if we look here at the entity relationship model, we can begin to see here how it may break down. What we want to do, and let's zoom out just a little bit here so we can see it. Let's adjust, and so let's take a look here. So obviously we know we have the car. We know how to identify the car with the car primary ID. Let's take a look at the primary ID. So we have the car table. We determined we needed a car table. One of the things are we want to determine all of the entities. So we know we have a car. We know we have a sales invoice. We talked about that, a salesperson, the mechanic, the service ticket, the customer, service parts used, and service mechanic. So that sounds like we covered all of the entities involved in this model. Now we have to, for each entity, take into account what the attributes are and also what the cardinality is. So we know for a car here the serial number, so we're going to have a car ID instead of a serial number for our primary key. We can see the PKs, the primary keys that were identified. It's an attribute, but it's a special attribute, as you know. Serial number, make, model, color, year, and car for sale, yes or no. So as we go through here, we want to think about these relationships. We already talked about that a sales invoice has one salesperson, so that's a one-to-one, but a salesperson can have many invoices. So we see here the one-to-many that's right here. We also here, we're seeing that mechanic, in our mechanic ID, again, a mechanic can service many vehicles, but a vehicle is only going to be serviced by one mechanic. And we see here a service ticket, the one-to-one here. So we have to think about here, what are the possible cardinality, and this is again called cardinality. If we also said that a customer could buy many cars, so or it could have many service tickets, and also this zero in here, a customer may not buy a car, so that's why it's zero to many, right? The customer may not buy a car because the customer may be there just for service, so that's why it's zero to many as far as cars to sales invoices. But a service ticket will always have at least one customer, and a customer may have zero to many service tickets. So this is a little more of a complex approach to putting together our entity relationship model. And I think the cardinality is going to be one of the trickier parts. But notice here there are also foreign keys. So as we put together our sales invoice, we want to look what are ways that we have to describe the sales invoice from other entities. And in this case, we can see we have the car ID, the customer ID, and the salesperson ID. And that makes sense. We have our sales invoice, and this is nicely placed right here so we can look back to the salesperson. So we see the primary key for the salesperson table here in the sales invoice. We have the car ID and also the customer ID. And one of the best uses for the foreign key, it definitely shows how they relate, how they link, but also we don't need all of this car ID information back in the sales invoice table. All we need is the car ID, and then we can bring in this information by simply querying the car table. And the same thing with the customer table, and the same thing with the salesperson table. And if we look over here too for the service mechanic ID, we can see we have the three foreign keys that we've identified. So we have the service ticket ID right here, and we have the service ID, and we also have the mechanic ID. So we're able to bring in all of this information from those tables. And likewise with the parts used, we're going back to the parts table. We're able to determine which part was used, and also the service ticket. Right, it's looking right back up here for the service ticket. So we've got to think about those relationships as we come down to our identities with our foreign keys. Those are the tables that will be relating, the ones with foreign keys, and those are the ones that we need to describe the relationship. So the foreign keys tell us how they relate. They also give us links back to the data. So when we are running our application, or we are simply running reports. So take a look at this. Again, go through these rules, see what you come up with. Go into either Visio, go into PowerPoint, and do your best to mock these up. Don't look back too much to the answer. You can always have it to reference, but eventually a DBA can take this and very quickly move this into what we call a physical data model, and that physical data model will be the schema or the template for our database, and then that database can be used obviously for an application. Could be a web application, could be a mobile application, or some kind of report type of application, report on sales and so on. But please do take a look at this. And if we scroll down a little bit further, we can see here that the exercises are from a database design. So when you're done, take a look at that as well.